What if everything you knew about space was just the beginning of a much deeper mystery? Space is not just an empty void. It's a three-dimensional continuum filled with positions and directions. In classical physics, space is often seen in three linear dimensions, but modern physicists view it as part of a boundless four-dimensional continuum known as space-time. The concept of space is fundamental to understanding the universe, yet philosophers still debate its true nature. In the 19th and 20th centuries, mathematicians explored non-Euclidean geometries, where space is curved, not flat. Einstein's theory of general relativity showed that space around gravitational fields deviates from Euclidean space. Philosophical debates about space date back to ancient times, with Plato, Aristotle, and Alhazen all contributing to the discussion. Isaac Newton saw space as absolute, existing independently of matter, while Leibniz viewed it as a collection of relations between objects. Galileo challenged the geocentric view of the universe, supporting the idea that the Earth and other planets revolve around the Sun. Descartes sought to replace the Aristotelian worldview with a theory of space and motion governed by natural laws. Leibniz argued that space is an abstraction from the relations between objects, not a continuous entity. Newton's bucket experiment demonstrated that space must exist independently of matter. Immanuel Kant believed that space is a property of our mind, a framework we use to structure our experiences. Non-Euclidean geometry, developed in the 19th century, challenged the long-held belief in Euclidean space. Gauss and Poincaré questioned whether physical space is curved, leading to new insights in geometry. Einstein's special theory of relativity combined space and time into a single construct known as space-time. In general relativity, Einstein proposed that gravity modifies the geometric structure of space-time itself. Modern mathematics defines spaces as sets with added structure, often using concepts like topological spaces and metric spaces. Space is one of the fundamental quantities in physics, explored through measurement and experiment. Our three-dimensional space is embedded in a four-dimensional space-time, known as Minkowski space. Relativity theory shows that space and time are not independent, but are intertwined in the fabric of space-time. Einstein's general theory of relativity predicts the existence of gravitational waves, ripples in space-time. Cosmology explores the shape of the universe and its origins, suggesting space was created in the Big Bang. The measurement of space has evolved, with the meter now defined by the distance light travels in a specific time interval. Geography uses spatial awareness to understand why things exist in specific locations, impacting fields like cartography and geostatistics. Ownership of space extends beyond land to airspace, waters, and even cyberspace. Psychologists study how we perceive space, which is crucial for survival and understanding our environment. Space-related phobias, like agoraphobia and claustrophobia, highlight the psychological impact of our spatial awareness. Social sciences examine space through various lenses, including Marxism, feminism, and post-colonialism. Henri Lefebvre's The Production of Space discusses space as a social product influenced by multiple processes. David Harvey's time-space compression theory explores how technological advances affect our perception of time and space. Edward Soja's third space concept addresses the complex ways humans understand and navigate space.